Large language models generate text, but they have no inherent knowledge of your company's proprietary data. To bridge this gap, we use Retrieval-Augmented Generation. You can think of RAG as a highly efficient AI librarian. When you ask a question, the system converts your query into a vector embedding, a long numerical array. It uses that mathematical structure to search your internal database and pull the specific text documents needed to ground the model in reality. But enterprise reality is rarely limited to neat paragraphs of text. Companies rely on medical scans, complex financial charts, and highly detailed network diagrams. To handle this variety, many systems use a method called Textify Everything RAG. This approach runs visual data through a basic captioning model, generating a short text description to store in the database in place of the original image. If that captioning model misses a detail in its summary, that information is lost. The AI is now blind to any visual detail that the text summary happened to omit. Imagine a network engineer asking an AI assistant to locate the blue failover links within a newly updated VPN architecture diagram. The captioning model recognized the diagram, but missed the routing colors, condensing the schematic into a generic sentence. Lacking the keyword blue, the search comes up empty. The document exists, but the system cannot find it. To bypass this broken search, developers created hybrid multimodal RAG. This method searches through text captions, but when it finds a match, it retrieves the full resolution image to send alongside the text. Working through a text proxy creates a severe bottleneck. Accurate retrieval requires the architectural capacity to process raw visual data directly. Delivering the image to the model is only the first step. The language model must possess the neural architecture to analyze linguistic and visual information simultaneously. Treecapital engineered the Anven 1.1 model to meet this dual processing requirement. It operates as a 3 billion parameter multimodal reasoning engine. This schematic illustrates Anven's late fusion architecture. Separate text tokens and encoded image tokens are fed into cross-attention modules, allowing the model to blend the features of both formats in a unified space. To activate this cross-attention layer mask, you must follow the structure shown in this prompting protocol. The special image token must be placed immediately before the text query. With this structure, the model can read a multi-page security policy and trace the red and blue routing paths on an attached network diagram at the same time. The final step in this evolution removes the text proxy from the initial retrieval process entirely. We call this full multimodal RAG. Using a specialized multimodal embedding stack, text documents, photographs, and audio files are mathematically plotted into a shared vector space. The search operates on semantic meaning, regardless of the file format. By combining this shared vector space with late fusion reasoning, the system retrieves and analyzes the actual visual data. The proxy bottleneck is removed. Once the system can process visual data directly, it functions as a reasoning engine, capable of performing logic-based tasks. To manage these tasks, we integrate the model with LangChain, an orchestration layer that allows the AI to manage and execute autonomous, multi-step workflows. This orchestration schematic details the pipeline. The central Anven model connects to the RAG module for retrieval, while a memory module persists conversational state. With this context, the agentic layer autonomously interfaces with external APIs or executes tools based on cross-modal data. Pumping raw, unproxied schematics and proprietary circuit diagrams into a public cloud model exposes a company's internal physical infrastructure to third-party servers. Anven operates as a sovereign AI, meaning the weights, the inference engine, and the entire RAG pipeline reside behind your corporate firewall. Effective enterprise intelligence relies on the ability to process visual reality without compromising the security of the underlying data.